Hi everyone, Mrs. Musoff here. I'm going to go through an extra example that's based on the notes from rates of change in tangent lines just to make sure we're really understanding it. I've heard it can be helpful to see me actually go through the example instead of have it already written down, so that's what we're going to do here. Alright, so example 1, it says given f of x equals 1 divided by x plus 2 and at x equals 0. Part A, find the slope of the curve. So we're finding the slope at x equals 0. Part B, find an equation of the tangent line. Part C, find an equation of the normal line, and then Part D, draw a graph containing all three. And by all three, it means f of x and tangent line and normal line. Okay. So for Part A, find the slope of the curve. Well, anytime we're looking for the slope, think rate of change, right? The slope of the curve at a single x value, that's always going to be the slope of the tangent line or the instantaneous rate of change. So the slope of the curve for part A is that equation we use, the limit as h approaches 0 of f of a plus h minus f of a divided by h. Where in this case, in any case, a is going to be the x value we're looking at. In this case, a is going to equal 0 because it's at x equals 0. So that's the limit as h approaches 0 of f of 0 plus h minus f of 0 divided by h. Now right here, 0 plus h, right, we know that's just h. And so now to finish evaluating this, I'm going to plug these values into my function. So this would turn into the limit as h approaches 0. If I plug in h here, I'm going to get 1 divided by h plus 2 minus, now I'm going to plug 0 in, so that'd be 1 divided by 2, or 1/2, all divided by h. Now, I can't evaluate this limit right now because if I were to plug 0 in, right here I would get divide by 0, and that's undefined. Right? So instead of evaluating the limit, I'm going to try and just work with this part, simplify it a little bit so that eventually I can just plug in 0. Alright, now this is a complex fraction, which means there are some steps we can take to simplify it. First things first is I'm going to get rid of this complex denominator here. And to get rid of the divide by h, I want to multiply by the reciprocal. And I just have to do it to the top, the entire top, and to the entire bottom. Okay, so on the bottom, h times 1 over h is just 1. But on the top, I'm going to actually have to distribute this. And remember, multiplying fractions, you multiply the numerators and then multiply the denominators. So I'll end up with the limit as h approaches 0 of 1 divided by h times h plus 2 minus 1 divided by 2h. Oops, sorry. There you go. And now once again, I still can't evaluate the limit because if I were to plug 0 in right here, it would still give me 1 divided by 0. So what I'm going to do is try and combine these fractions and hope that in that process I'll be able to simplify the h out and then I'll be able to substitute. Okay, so to subtract these fractions, I need common denominators. That means this denominator needs an h plus 2, and so I have to give it to the numerator also. And this denominator needs a 2, so I'll give it to the numerator also. Alright, now these denominators are the same, so I know I can actually combine these. The limit as h approaches 0. So in the denominator, I have 2h plus 2. But in the numerator, 2 times 1, that's 2, minus, and then the quantity h plus 2, because distributing that 1 doesn't change it. Alright, make sure you keep those parentheses there because you are going to have to distribute the subtraction. It's okay if you skipped this step and went straight into distributing the subtraction. So then you would have ended up with 2 minus h minus 2. And that means 2 minus 2 is 0. So I'm going to swing it up here. The limit as h approaches 0, now I have negative h divided by 2h times h plus 2. And this is what we are hoping to get to because now I can see, oh, h in the numerator, h in the denominator, those can simplify. And so I'll have the limit as h approaches 0 of just negative 1 in the numerator divided by 2 times h plus 2. right? Now, if I were to substitute 0 in, I won't get divide by 0, so I won't get undefined. So that means to evaluate this limit, that's exactly what I'm going to do. Okay? So my slope, sorry, I should have been writing this the whole time, m equals, right? This is what I'm calculating. M equals all of this. So now at the end, I'm going to bring it back since I forgot. M, the slope, is going to equal plugging in that 0. So negative 1 divided by 2 times 0 plus 2. Right? That means my slope, m, would be negative 1 divided by 4. And so there's the slope of the curve at x equals 0. Okay, so now for part B, I've already done all the heavy lifting. All right, so for part B, there shouldn't be too much extra to do. It says, find an equation of the tangent. Well, that requires a slope, which I just found, negative 1/4. And it requires a point. Well, remember, the point that we're using is going to be at the x value that we're given, so x equals 0. And anytime you're given an x value, to find the y, you just plug it in. So the point that I'm going to use is going to be 0 and then plugging in 0, so f of 0. All right, and if I plug in 0 to the function, I'll end up with 1/2. So my tangent line equation is going to be y minus 1/2 equals the slope times x minus 0. Now x minus 0, we don't have to write it like that. X minus 0 is just x, so this is really negative 1/4 x, and I'll leave my equation like that. Alright, for part C, now C is asking for the equation of the normal. The only difference between the tangent and the normal is they're perpendicular. That means this slope is going to change. It's going to be the opposite reciprocal slope. So instead of negative, it is now positive, and instead of 1/4, it is 4. Alright, opposite reciprocal. I'm still using the same point because this line is happening through the same point. It's just perpendicular. So my equation will be y minus 1/2 equals 4, and then just times x, or x minus 0. Okay. For the last part, part D is asking for the graph. Here you go. Alright, and so that means I'm going to graph the original function first, which was f of x equals 1 divided by x plus 2. That's just the reciprocal function. Shifted left 2. So left 2, asymptote, asymptote. I know it's bottom heavy. And I'm just going to approximately draw it, but if you wanted to, you obviously could find a couple points just to help guide you. Alright, so there's my graph of f of x. And then I am going to graph the tangent line. The tangent line is happening at the x value 0. So that means you could actually, graph the tangent line specifically if you wanted, or we can just kind of approximate at x equals 0. That would be right here, this point. And so if I wanted the tangent line, it should be just touching that point, no other point on that graph, so something like that. That would be my tangent line. Alright. If I wanted the normal line, it should also go through this point, but it should be perpendicular. Right, so that right there is my normal. It is perpendicular to the tangent. Alright, and then that's it. Hopefully that helped kind of explain some things. If you have any other questions, just make sure you write them down and ask your teacher. Thanks again.